All right, let's get started. This is probability of compound events. Okay. First, the key word here is compound. If something is compounded, what does that mean? Well, kind of. It can be together, it can be more than one. All right, more than one at the same time. Okay, so there's two types of compound probabilities. Okay, one of them is independent. Okay, independent probability, compound probability. Okay, independent compound. What if something is independent? What does it mean? Okay, one outcome doesn't affect the other. In other words, if I flip a coin and I roll a die, does what I flip on the coin have anything to do with what I roll in the die? No. Even if I flip a coin 3 times, does the second flip have anything to do with the first flip? It doesn't have any bearing on that, okay? That's an example of independent compound probability, okay? One outcome does not affect the other. Okay, so let's say I present a problem to you, okay? And I say 2 number cubes are rolled. Okay, what is the probability? Okay, let's say 2 number cubes, 2 die. I'm just going to call them dice. Even though that's incorrect, it sounds better. Okay, 2 dice are rolled. Okay, a red die, a red one, and a blue one. Okay, and let's say that I want to know what is the probability that the outcome of the red number cube is even. Okay, so the probability of the red even. And now, this is a key word. What we saw before, we've seen the word or there. Okay? Or meant either one was okay. What does and mean? This has to happen, doesn't it? This has to happen. And let's say a blue 5. Okay? I want to know the probability of a red even and a blue 5. Does the blue 5 have to happen? Yes. Because I want what has to happen here. I have to get a red even, and I have to get a blue 5. You understand? Okay. So what I'm going to do is I'm going to go to each one of these and find each individual probability. What's the probability of me getting a red even number? How many even numbers are on a number cube? 3. There's 1, 2, 3, 4, 5, 6. 3 of them are even. What would 3 6 reduce to? 1/2. Right? Okay. But don't write them as percents yet. Okay? Now, let's go back to the die. If I roll a die, how many 5s are there? 1 out of how many? 1 out of 6. Okay? So what I'm going to do is I'm going to take those and I'm going to replace them. Red even was 1/2. Blue 5 was 1/6. And all I'm going to do is multiply the 2 probabilities together. Okay? The 2 ratios. So 1 times 1 would give me what? 2 times 6 would give me 12. So I would have a 1 in 12 chance of this and this happening. Okay, and if I was to write that as a percent and a decimal, what would that be? 0.083, or about an 8.3% chance, right? And if I was to round that to the nearest whole percent, I'd have about an 8% chance of rolling an even number and rolling a 5 on the blue one. Okay? Does that make sense? Now, these are independent because does whatever I roll on the even, does it have anything to do with what I roll in the blue? No. It doesn't affect it at all, does it? Okay? Do you understand what I mean by that? Okay. Can I erase this? Yes? All right. So let's say I put little sheets of paper, okay, and I number them 1 through 10. Okay? I number them 1 through 10. Okay? And let's say I want to also roll a die. Okay? Those are 1 through 6. Okay? Let's say if I wanted to find the probability of a 10 and 3. Okay? How am I going to find the probability of both of these things happening? What's the probability of me getting a 10, first of all? How many 10s are there on these papers? 1. 1 out of how many? 10. How many 3s are on a number cube? 1 out of how many? Out of how many? 6. And all I'm going to do with these 2 is multiply them. What's 1 times 1? Over 60. I would have a 1 in 60 chance. Now, I'm not going to make you guys write these as percents and decimals. Just leave them as a ratio. Okay? 1 out of 60. I would have a 1 in 60 chance of pulling a 10 out and rolling a 6. Okay? Does that make sense? What if I said this? Probability of 2 numbers less than 4. Okay? Well, I got to think about this for a second. Okay? Remember, these are 2 independent probabilities. They're 2 separate probabilities. What's the probability of me getting a number less than 4 on these sheets of paper? How many are less than 4? 1, 2, and would I include 4? No. So 3 out of what? 3 out of 10. And what's the probability of one that's less than 4 on a number cube? How many are less than 4? 1, 2, and 3 out of what? 6, which I can reduce to what? 2, 1/2. Okay? So now when I multiply these, 3 times 1 is, and 10 times 2 is, so this would be a 3 in 20 chance. You can't simplify this one, but if you can, yes. Yeah. All right. Does that make sense for independent probability? It's not that difficult. Okay? Are we good on that? Okay. All right. Now, the tricky part is dependent probability. Okay? What do you think dependent compound probability means? Right. If independent means one outcome affects the other one, independent means one outcome does not affect the other one. Dependent means what? Yes. One outcome does affect the other. Okay, so here's the thing. I can't really have dependent probability with a number cube or with a flipping a coin. Why? If I roll a number cube, can I change what the next one is on that number cube? I can't, because it's like it's a number cube, right? It's not going to change. Okay? So how do you think, like when we were doing Skittles, when we were drawing Skittles out of a cup, okay, do you think that's a way that we could use dependent probability? Because I can I affect the total outcomes on a number cube? I can't. Can I affect the total outcomes on a coin if I flip a coin? Can I affect the total number of outcomes on a cup of Skittles? Yeah, I can take one out, right? Okay, so let's say, let's say I got a cup of Skittles. I have six red Skittles, and I have 4 green, and I have 3 yellow, and 2 orange. Okay, first thing I need to determine, how many Skittles are in the cup? 15 Skittles. Okay, 15 total. Okay, now let's say that I wanted to find the probability that the first Skittle, first is red, then a yellow. Okay, here's what I have to do in this. Okay, when I see that something is dependent probability, okay, usually there's going to be a statement that says that first one is not replaced. In other words, I have that cup of 15 Skittles, right? How many of them are red? I'm going to find out probability that are red. How many of them are red? 6 out of what? 15. Can I reduce this? To what? How many 3's going to 6? How many 3's going to 15? Okay. I reduced it. Okay, but here's where it's tricky. Okay? I reduced this number. Okay, but if I took one Skittle out, okay, regardless of whether it's red or not, how many Skittles are left? Okay, everybody should be telling me this. If I took a Skittle out, how many are left? 14. Okay, so I don't want to use this second one, because if I took one of these out, I'm not going to use a 4 here. Does that make sense? This is a reduced amount. Okay, so I would wait to reduce this until after we find the compound probability. I'll show you what I mean by that. Okay, how many are yellow in the cup? 3. But this is no longer 3 out of 15. What is this? 3 out of 14. Okay, because I took a Skittle out. Okay, so when I multiply these, now I can reduce this. What can I reduce 6/15 to? To 2/5. Okay, can I do any cross canceling here? What can I cancel? I can't cancel 3 and 5, but what can I cancel? 2 and 14 to what? 1 and 7. Now let's multiply. 1 times 3 is? And 5 times 7? 3 and 35. That means if I did this same experiment 35 times, according to this, 3 of those times, I would get a red and then a what? Then a yellow. Okay? Does that make a little bit of sense? Yes? Okay. Now, sometimes it can be more than one. Okay, what do I mean by that? Let's say I've got something like this. I want to find, did you guys write that down? Let's say I want to find the probability of drawing 3 greens in a row. Now, when I say that, my first one has to be a what? Green. My second one has to be a, and my third one has to be a green. Okay. So the first one's easy. Why? Because how many Skittles are, I put them all back in the cup. There's how many out of 15? 4 greens out of 15, right? Now, I took one of them out. But not only did I take one Skittle out, I took a what out? It has to be a green, doesn't it? So how many greens are left? 3. How many Skittles are left? 14. I took a second green out. How many greens are left? 2. Out of how many? 13. Okay. Now, when I multiply these, okay, is there anything I can cancel here? I can cancel 3 and 15, right, to 1 and 5. Can I cancel 2 and 14? To 1 and, can I cancel 4 and 13? No. So what's 4 times 1? Times 1? 4. And what is 5 times 7? 35 times 13. What is that? 455. Okay. Can I reduce this? No. I can't. 455. Okay. Does that make sense how we do this? Yes? Okay, now, every time you have a new problem, like let's say this was number 5. When I go on to number 6, it means everything's put back in. Okay? It doesn't keep compounding. Does that make sense? All right, so if I put them all back in there, you guys tell me what the probability would be of an orange, then a red, and then a yellow. See if you can find that probability. I draw one, draw another one, draw another one. Raise your hand when you have an answer for that. Let's see. Okay. How many orange are there, guys? How many? 2 out of how many? 2 out of 15. Okay, I took a Skittle out. How many are left, first of all? 14. How many are red? How many? 6. Okay. No, I didn't take a red out. There's still 6 red in there. Okay. How many yellows are there? 3 out of how many? 13. Okay. Now I'm going to multiply these. Can I do any canceling here? I can do what? I can do the 3 and the 15. So 1 and 5. And 1 and 7. Can I do any more canceling? Okay, 1 times 6 is 6 times 1 is what? Now, is this the same as last time? So 6 out of what? 455. Okay. Pretty easy stuff once you get it, right? It's not that bad. Does that make sense? Okay, you ready for your worksheet? Okay.